All right, good luck on problem 3.2. Hopefully this went well for you. This one's harder because the derivative is more complicated and the algebra is a little bit more complicated. But the first thing we're going to do is the same thing we've done on all the other problems, and that is we're going to find the critical points. And so that means we have to take the derivative of this thing. So our derivative is going to be the quotient rule. Again, you all have gotten really good at your derivatives, so I'm not going to write out all the details of this quotient rule. Instead, I'm going to write the derivative of the top, which is 2x times x squared plus 1 minus the top times the derivative of the bottom, which is 2x, all divided by the bottom squared, x squared plus 1 squared. This is one where doing a little bit of algebra is actually going to help us. So let's simplify this just a little bit. Oh, this is a derivative. So let's multiply in there and we'll get 2x cubed plus 2x minus, and notice this is 2x cubed, all divided by x squared plus 1 squared. And now let's do one more step because you notice we have 2x cubed and minus 2x cubed, so y prime is actually just 2x divided by x squared plus 1 squared. So this is a much friendlier equation. First, we have to ask, could this ever equal 0, or could this ever not exist? Well, what if the denominator was 0? If the denominator was 0, it doesn't exist, but notice, can this ever equal 0? Well, if this were to equal 0, that would mean x squared plus 1 would equal 0, which would mean x squared was equal to -1, and x would be an imaginary number. So the answer is no, this always exists because only imaginary numbers make the denominator 0. So y prime always exists. So we don't have to worry about the derivative not existing. So now all we have to do is we just have to set y prime equal to 0 and see what happens for that problem. So when y prime equals to 0, we're going to have 2x divided by x squared plus 1 squared equals 0. And this may look really, really intimidating, but it's actually not bad at all because all we have to do is multiply by this denominator. The denominator is not 0, so we multiply by that, multiply it over, and notice when we multiply both sides by the denominator, we get 2x equals 0 times that denominator, but that's just 0. And so 2x equals 0 is our problem, and x equals 0 is our critical point. So this problem only had one critical point, and it's the x equals 0 critical point. Okay. Next, we have our endpoints. We know what our endpoints are. Those are from the problem. So what if we go number 2, endpoints are x equals -1 and x equals 3. I feel like being lazy, so I'm just going to write those there and jump straight to the plug-in step. The plug-in step, and when we plug in, we plug in these two endpoints and this critical point. So we plug in f of 0, f of -1, and f of 3. So this is a critical point, and then this is an endpoint, and this is an endpoint. So we got our critical point, endpoint, and endpoint, and we plug them into our original equation. So this goes to 0 squared over 0 squared plus 1, and so 0 is what that critical point gives us. -1 would give us -1 squared over -1 squared plus 1. So this is 1 over 1 plus 1, which is 1/2. Finally, this last one, I'm going to need a little bit of extra space. This is 3 squared over 3 squared plus 1, and so this is 9 over 9 plus 1, or 9/10. And so as I look at these, I can already see my biggest number. This 9/10 is my largest, and my smallest number is this 0 right here. So let's write out the answer nice and neatly for our professor. And so the answer is 9/10 is the max at x equals 3, so that's the value we put in, and then 0 is the min at x equals 0. Okay, hopefully that went well. Again, the derivative is a little bit more challenging. The algebra looked really intimidating, didn't it? This algebra looked really hard, but it actually wasn't hard at all. You multiply by the denominator, and the problem becomes quite simple. Okay, you're ready for the last one that we're going to do in this section, and it's a trig problem, so good luck with that.